quick review on solving systems of linear equations by graphing. So a system of equations is two or more equations. We're talking only about linear equations, so they're going to be graphs of lines. And we are just quickly reviewing, okay? So what is a system of equations? It's a group of more than one equations. What is a solution to a system of equations? A solution to a system of equations is a coordinate pair that satisfies all equations in the system. On a graph, what's that look like? It's where the lines intersect. All right, what does it mean to satisfy an equation? All right, that means when you plug in, so, right, it's a coordinate pair, so that means an x and y coordinate. Okay, when you plug in that x and y number from the pair into the equation, it makes that equation true. It makes the left side of the equation equal to the right side of the equation. It satisfies that equation. All right, so the solution to a system is a coordinate pair that satisfies all equations in the system. Usually we just have two equations to satisfy. On a graph, it's where they intersect, okay? And that's what we'll be focusing on here. All right, so here's an example. All right here is our example. Here are the two equations, okay? 2, 1 is the solution to the following system of equations. All right, so it's where these two lines cross. You can see that's the x plus y equals 3. Okay, this is the line of all the points that if you took the x and y coordinates and added them, you'd always get 3. All right, and then this is the equation here where the y is always equal to 3 times the x minus 5. All right, so these are my two main equations. For this one, I graphed it using intercepts, right? I found the x-intercept and the y-intercept. And this one I just used slope-intercept. It's in slope-intercept form, so I could just plot the y-intercept and plot other points using the slope. Okay? Now, what does it mean to satisfy this equation? Okay, so this solution is where they intersect, but we can also check our answer here by checking to see if 2, 1, that's this point right here, over 2, up 1, okay, does that point satisfy this equation? And does that point satisfy the other equation? The two equations that we have in our system. All right, what does it mean to satisfy? It means we're going to plug in the values for x and y into these equations and see if it makes them true. All right, so we have the y, we're going to replace with 1. We have the 3 times the x value is 2, and then we have minus 5. We just simplify. There's no solving to do here. We're just simplifying. We're just doing the operations that are there. So 3 times 2 is 6, minus 5, and then we get 1 equals 1, because 6 minus 5 is 1. Check. So this coordinate pair satisfies this first equation, because when you plug it in, it makes the left side equal to the right side. All right, let's see if it satisfies the second equation. Then we can truly know that it is, in fact, a solution to the system. All right, so we have the x plus y equals 3. We're going to plug in the 2 for x. We're going to plug in the 1 for y. And I can see it already. We simplify that left side, and it does work out that the left side is equal to the right side. So this coordinate pair satisfies that equation as well. It satisfies both equations in the system, so therefore it is a solution to that system. All right, there's only one solution in this case because they cross like that. All right, there are two other types of situations that can happen, and those will be shown in this little diagram here. All right, there are 3 possibilities when solving systems of linear equations. The lines can cross, so there's one solution. The lines can never cross. They can be parallel, so there's no solution. There's no one point that will satisfy both of those equations. Okay, so no solution, parallel lines. And why are they parallel? Because they're at the same slant, which is determined by their slope, so they have the same slope. And the last one is here. lines on top of each other so it looks like they are one line. This is called infinitely many solutions because when the lines are the same exact lines, every single point will satisfy both of those equations because guess what? They're actually the same equation. All right, the equations are actually the same equations, just in different forms. So maybe one was written in standard form and the other was written in slope-intercept form, and when you graph them, you're like, wait a minute, they're the same line. Okay, closing in on the end here. How do we graph? Okay, some quick reminders. Graphing slope-intercept, y equals mx plus b. Remember, write down the slope, which is the m, and the y-intercept, which is the b. Okay, then you plot the y-intercept. From the y-intercept, use the slope to plot other points. Okay, so if the slope is positive, you're going to go up and right. And if the slope is negative, so positive slope, negative slope would be down and right. Okay, down and right. So up and right, down and right. We always go right, okay, for slope. Anyway, last little section here. How do we graph when something's in standard form, right? We find the x and y intercepts and plot those 2 points, then graph a line through it. Find the x-intercept by plugging in 0 for y and solving for x. And 2, find the y-intercept by plugging in 0 for x and solve for y. All right, plot the x-intercept and y-intercept and then strike a line through them. Okay, that is our review. All right, what we're going to do next is, oh boy, we're gonna not graph. We're just gonna solve a system of linear equations algebraically. Getting all algebraic in here. Okay, you're gonna join my new club and I'll be my algebros. Okay, I've been waiting all year to use that joke. Now, we got no graphing, which you might be saying yay to start if you don't like graphing, but I think you might be a little disappointed because this is a lot of work actually, which some of you will find very intriguing and fun, I'm sure. All right, we have the substitution method, aka the dub sub. All right, double substitution, and you'll see what I mean. What is substitution again? Anybody know? Okay, substitution, right? Just like a substitute teacher could come in and replace me, all right? When you have something that's equal to something else, you can replace it with that thing, all right? You've done it a lot when we have those problems that say evaluate when a equals 4, right? It says a is equal to 4, so wherever there is an a, you can put a 4. All right, when you know two things are equal, you can replace one with the other. All right, I don't know if you've ever seen, what is it, Indiana Jones, where he's like in one of the his treasure hunts, and he has to like take this idol off of this stand and replace it with something of the equal weight perfectly, or else the booby traps will start like flying around and it'll try to kill him. Okay, and he has to replace it with the perfect same weight. Okay, that's substitution. All right, maybe I'll send you a video of him in that part of that movie. Great movie, you should check it out. Indiana Jones and the Quest for the Holy Grail, is that it? Or Raiders of the Lost Ark? I'm not sure which one it is in. I'll have to check that out. Anyway, moving on. We have substitution method, okay, aka the dub sub. Okay, we're going to be solving systems. Here's a system of equations. When we would graph it, right, we'd graph both of these and see where they cross, and then where they cross would be the solution. Well, now we're going to do something a little different. No graphing. Okay? All right. We want to copy all this down because the system is it's going to take some practice, and you're going to have to use this as a reference so that you can get that practice. All right. So first step is to wisely choose one equation. So there's two equations. We're going to just choose one of them. I chose this first one because it will just work out better in the long run. You'll get the hang of which one to choose. You could have chosen either one in this case. Sometimes there's going to be a better one to choose. All right, so you write down the first equation. All right, step one. I think you can get that far. Choose one of the two, write it down. Step two, use the other equation to figure out what to substitute. Okay, so I'm looking at this second equation here. I already chose this equation to write down. Now this is going to tell me, this second equation is going to tell me what to substitute. So it says y equals 2x. Remember what I said about substituting. If you know two things are equal, you can always replace one with the other. All right? So, since the second equation says that y is the same as, is equal to 2x, we can replace the y in the first equation with 2x. That's the leap that is really difficult for some people to realize. Okay? We are going to take this first equation and we're going to look at this second equation and say, oh, y equals 2x. So we go back to the first equation and say, okay, wherever there's a y, we're going to take it out and we're going to substitute it in with the 2x. Okay? So now it's kind of like half and half now. We got half of the old equation and half of the new equation. All right, and that's going to help us solve and figure out what the solution to this system is. All right, so now we've completed that first substitution step where we substitute a piece of the second equation into the first equation. Now, number three. Okay, number three, we're going to solve that equation, that new equation that we substituted in for. We're going to solve that equation for the remaining variable. And the remaining variable here is x. All right, we're going to need a little practice here with solving equations, but when we solve 2x equals 1x minus 3, we notice that there's an x on both sides, right? An x term on both sides. When we want to get rid of a term, we just use subtraction or addition. So we're going to get rid of this 1x by subtracting 1x. Subtract the 1x on this side as well. All right. We get 1x equals negative 3 because we bring this minus 3 down. All right, and essentially that's the same as x equals negative 3. So we're not done, okay? That is half of our answer, because what is our answer to a system? Our answer to a system is a coordinate pair. A coordinate pair. We only have half of that pair. We have the x coordinate. How are we going to find the y coordinate? Well, here we go. Our last couple steps. Okay, now we know that x equals negative 3. Whenever we know that something equals something else, we can use that in a substitution. We can replace x's with negative 3's, okay, because we know they're equal. So step 4 is substitute solution, our solution, right? To step 3, substitute our solution into one of the original equations. What are the original equations? These guys up here. Okay, we're going to substitute our solution from step 3 into one of the original equations and solve to find the other coordinate for the solution to the system. All right, so look what I chose. I chose to do, oops, that's not the right step. There, right here. I chose right here with step 4. I chose to do y equals x minus 3, and I'm going to replace the x with what I know it's equal to. I know x is equal to negative 3. So what do? I take out the x, I put in a negative 3. Y equals negative 3 minus 3, so y equals negative 6. All right, now that's the other half. So I have that part and I have that part, and I put them together to get my answer of negative 3 comma negative 6. Okay, our last step is to write the solution as a coordinate pair. Here's our solution. And if we were to graph that, that's where the two lines of these equations would cross. Now, if I were to substitute into these equations, right, our -3 comma -6, they will satisfy both equations. So if I put the -3 here, 2 times -3 is, yes, -6. So if I put a -6 here and a -3 here, it would satisfy the equation because both sides of the equation would be true. If I put -6 here and -3 here, would it satisfy that equation? Yes, because -3 minus 3 is -6, and that would be -6. Okay, that is our method for today. It's called solving systems of equations algebraically, and it's called the substitution method. So we're moving on to example 2. Now we are going to find the solution to this system. Why is it a system? Well, it's two equations using the same variables. We're trying to find out what coordinate pair would satisfy both equations, or what coordinate pair would be the intersection of these two lines. All right. So our first step is to choose one of these equations to be our starting equation. Now this time it's important to choose the one that doesn't have the y isolated. Okay. Right, choose the one that doesn't have a variable by itself. All right, and by itself means this y. It's lonely over here because the equal sign separates it from all its buddies, 3x and the 8. Okay, the y is isolated. The y is by itself. We're not going to choose that one because that's the one we want to actually use to help us substitute in step 2. Okay, so here we go. So we're going to choose this. Step 1, choose 8x plus 4y equals 12. Step 2 is to substitute in according to the other equation. Wow, this one is crazy. What does y equal? Right? It tells us that y equals 3x plus 8. So wherever we see a y in here, we can replace it with 3x plus 8. So watch this. I'm going to take 8x plus 4. Now I'm going to take out that y. And what does my equation say is equal to y? Y equals 3x plus 8. So I'm going to substitute in 3x plus 8 for that y. Everything else is the same. The 8, the x, the 4, the 12, the equal sign. All I substituted was 3x plus 8 in for y. All right, now we have to simplify and solve. Here we go. Distribute first. I get 8x plus 4 times 3 is 12x. 4 times 8 is 32 equals 12. So step 3 is to solve for x. And to do that, I need to simplify first. I can combine these like terms and get 20x plus 32 equals 12. And now everything's simplified, so now I can solve. All right, minus 32. That gets us negative 20 equals 20x. And divide by 20, x equals negative 1. I know you wish you were done right now, but you're not. You're halfway there. You got what the x coordinate to our solution is, but not the y coordinate. When we're solving systems, we need a coordinate pair. So we only have one of those pairs now. Now our last step is to take either one of these equations, substitute in our answer here, our first half of our answer, to help us get the other half. Okay, so which one do you want to do? I'm going to do this one. It looks simpler to me, but you can do either. So I'm going to do y equals 3x plus 8. And I'm going to go y equals 3 times negative 1 plus 8. Why? Because of this, right? It says x is equal to negative 1, so wherever I see an x, I'm going to put in a negative 1. Okay? And we get y equals, that gives us negative 3 plus 8. So y equals negative 3 plus 8 is 5. Okay, so now we have our two parts of our equation. Our last step, fifth and final step, is to write it as a coordinate pair. Negative 1, comma 5. And that is the coordinate pair. Whoops. And that is the coordinate pair. All right, I took the x coordinate and the y coordinate. That's the coordinate pair that satisfies both of these equations. Okay, it's negative 1 comma 5. And so I have, if I were to put it in here, I put the 5 for the y and the negative 1 here for the x. That'd be 3 times negative 1 is negative 3 plus 8 would be 5. So this side would be 5, that side would be 5. Let's see if it works over here. We would have 8 times negative 1, which would be negative 8, plus 4 times 5, which would be 20. Negative 8 plus 20 would be 12. So 12 would equal 12. So it satisfies both of those equations, so we know we are correct. This is not easy, and there are so many places where you can make mistakes, but perseverance and a lot of asking questions will help you through it. I have complete confidence that you guys, if you work hard enough, will get this. All right, good luck.